everybody, this is Alex Merced with another video on data modeling. This is actually the last video for the Intro to Data Modeling playlist. And we're going to talk about what is a star and Snowflake schema. So essentially, these are just different approaches, particularly when you're building a data warehouse. So again, oftentimes on the operational side, you probably prefer all your data to be normalized, so broken up into as many little tables to reduce sort of data repetition, to improve data maintenance, because you're doing a lot of changes to the data. Because transactions are happening that are either creating or updating records. Now, once you move data into your analytical systems, into let's say a data warehouse or a data lake house, you're no longer necessarily creating new records, and any updates you're doing is really more like in the data cleanup, data validation. You're not necessarily you're not taking in new transactions. So in that case, you're less trying to optimize for writing and trying to optimize for reading. So this is why oftentimes tables become denormalized. But again, the more you denormalize, the more repetitive rows you have. Okay, so the idea is always trying to find sort of how to sort of manage this. So in a star schema, what would happen is that you would have a fact table. Okay, and this is just basically, so let's pretend this is like a sales table, right? So basically we would have like an ID, okay, and then maybe we'd have an ID for a sale. So there'd be like a sale ID, a customer ID, okay. Let's see here. Let me just try to think of a few more. Customer ID, region ID, and a date ID. Okay, and then maybe a product ID. Okay, so basically this table would just have references to the different IDs from external tables. It doesn't actually have any of the data in itself. What you would do is that you would then have dimension tables surrounding it. Okay, so it'd be like 1, 2, 3, 4, 5. Okay, and this would just be basically, and then that would be it. So any layers that would have gone beyond that would be denormalized into these other tables. So this would be like your sales table, your customers table, your region table, and each of them would have like more details, like, okay, this is the region, here's the region's manager, here's the region staff, here's the region whatnot. Okay, here's the details of the sale, the dollar amount of the sale. Here you'd have like the customer data. So here you would find like the customer the customer who was doing the selling and all their information. Here you would have like the date, and the date might actually have other information like, is it Q1, is it Q2, what year, fiscal year. So that way there's more information for categorizing it into different ways. And then you might have a product table that has all the details of the product, like what product category it's in, all this stuff. But all of that would be denormalized. So you wouldn't have necessarily like a category table for your different category of products. That would have been denormalized into the product table. So the idea is that everything's flattened up to this point and then connected through the fact table. Okay, thus it kind of looks like a star. So that's a star schema. Okay, so that's where you get this whole star schema deal. Okay, and this is going to be good for reads, right? Because again, the more denormalized the data is, the less joins you have to do. Okay, which means, one, if you're doing less joins, the queries get less complicated. The only catch is you're storing a lot more data. Okay, you're storing a bit more data because you're having a lot. When you denormalize, you create those redundant records. Okay, where like again, thinking of a product, that product may be listed 30 different times, depending on sort of the nature of how it's denormalized. So in the case yeah. Now a Snowflake schema, oops, forgot to bring over the date table. Okay, the Snowflake schema, what you do is like you would actually have some normalization. This would actually reduce the amount you're storing, because since there is some level of normalization. So in this case, maybe let's say there's a categories table for different product categories. So that way you don't have to repeat that name of the same category over and over again. So you just reference it. Okay. There may be a managers table, so that way you don't have to repeat the name and information about the same regional managers over and over again. Okay, there may be sort of a sales agent table. And the idea is you're breaking up the table even more. And again, this could be multiple, but you start seeing it becomes it becomes a little bit more complicated when you look at it from the outside. So it looks more like a snowflake than just a star, because of that sort of more honeycomb type appearance when you start really kind of imagining how all these tables start forming when you start having all these tables branching out from that second layer. So that's a Snowflake schema. Benefit of this, you store a lot less data because again, that all that agent's information is not being restated for every sale they made, because in this case, if it was denormalizing the sales, that agent's phone number, all the information about the agent is being restated on every sale that they have because it's denormalized. Same thing for the manager, same thing for the category. So that's a lot of repetition of the information. But here the queries are going to become more complicated because now I have to join. First, I got to make sure I join and recreate my sales table. Join it with its dimensions. So I have to join this table with its dimensions before I can join this table with its dimensions. So the queries, the joins become a little bit more complicated. And then two, it takes a little bit longer to read because you're doing those extra joins. Okay, and that's fine, but then you might want this is where you start having to optimize and start doing things like materialized views and whatnot. Where in a tool like Dremio, you could just do reflections. That makes this much more viable and easier to maintain. But overall, this can get a little harder. But again, if storage costs are a big driver, then this is a possible way to go. Okay, but again, the idea here is this is more for on your analytics side. How do I approach curating my data, warehousing my data for analytics? So it's no longer operations. So in that case, the denormalization, the repetitiveness is actually an advantage because again, if you're not the less joins you do, the faster the query. Joins can be slow, especially with large amounts of data. So again, if I denormalize the data as much as possible, again, the star schema, that's going to be much faster for reading because I'm really just joining this. I'm not joining this, then this. Okay, so hopefully that helps you kind of appreciate the difference between sort of star and snowflake schema conceptually, and sort of like the why. And then hopefully you've enjoyed this whole series on data modeling, where we've discussed all sorts of different data modeling patterns that can be used in all sorts of different use cases. And there's much more beyond that, but this will kind of gives you sort of that initial sort of understanding of data modeling. And yeah, we'll probably maybe revisit again at some point in the future, but we got some other topics to hit along the way. So I'll see you there.